So in this video we're going to look at calculating the length of any side using Pythagoras' theorem. So we're used to finding the hypotenuse, the diagonal, and that's what we did in the previous video. But in these examples we're going to look at finding one of those perpendicular sides, either A or B. So let's just start off by making sure in this example we know what's what. This one, we'll call it C, is the hypotenuse, the diagonal. We can call this one A perhaps, and this one B. And remember that A and B are interchangeable. This would work just as well if I'd labelled that side X as being B and the 24 as being A. It doesn't matter. So we know Pythagoras' theorem, which is that A squared plus B squared is equal to C squared. So we'll put those numbers in and let's see what happens. So we're going to have that X squared plus 24 squared is equal to 26 squared. Now we could rearrange this a little bit, couldn't we, to work out what X is, and it's going to involve a subtraction. We could say that X squared is going to be equal to 26 squared take away 24 squared. And this is the key point to remember. When you're finding the A or the B, it's going to be a subtraction. We could even go a step further and we could say that X is going to be the square root of 26 squared take away 24 squared. Now if we type that in our calculator, we're going to get the correct answer straight away. So in this case the answer is exactly 10 centimeters. On to the second example, and this is a little bit more of an example in context. We've got to do a bit of extra work here. We've got to work out the perpendicular height of this isosceles triangle, and perpendicular height means at 90 degrees to that base. So we're looking to find the length of that dotted line there. Now, if the dotted line falls in the middle of this isosceles triangle, then we can sort of create a smaller triangle, either the left or right side of that dotted line. And so if that's the case, the hypotenuse is going to be 6 still, but one of the values A or B is going to be just 2 centimeters. So this leads, if we call the line X, that X is going to be the square root of 6 squared take away 2 squared. So remember that 2 comes from the fact that we're halving that 4, and so that's going to be the length of the sides of our right angle triangle. And please remember that Pythagoras' theorem only works for right angle triangles. We couldn't do it on the original picture because it's not a right angle, it's an isosceles. That's why we've had to do this. Now if we calculate that on our calculators, we're going to end up with 5.7 centimeters. And that's rounded to 1 decimal place. On to the next examples. So let's just quickly check we can do this. This of course is the hypotenuse, 2.5 centimeters in this case. Let's do them both at the same time. This one as well is the hypotenuse on that case, the 26 meters, and we can just label the other two as being our A and our B as we wish. Either way, we know that in this case that 2.5 squared minus 1.5 squared is going to be R squared. On this right hand example, we know that 26 squared take away 10 squared is going to be R squared. So working out R, well in this case R is going to be, if we just square root both sides so you see where it comes from, as the square root of 2.5 squared take away 1.5 squared. On the right hand example, R is going to be the square root of 26 squared minus 10 squared. So all that's left to do is to input these into our calculator. So the first one generates an answer of 2 centimeters, and the second example, when you input that on your calculator, will give us an R value of 24 meters. And those are the answers to those two questions. Now, we better have a look at some more challenging examples. These two are particularly difficult. You have to break them down into little pieces and then try to build your answer up from there. So if we look at the left-hand example first, The first thing we need to determine is x, and we can determine x because x is the hypotenuse of a right-hand triangle with A and B being 3.8 and 6.4. So we can work out what that is by doing the following. The square root of 3.8 squared plus 6.4 squared. Now if we work out that, we get our x value to be 7.443. Now we can use that in the top triangle to find out what y is, because it's still the hypotenuse of that top triangle. So we can work out y by doing 7.443 squared, take away 4.2 squared, and then square rooting the whole thing. And if we do that, we're going to be left with a y value of 6.1. Okay, on to the final example, and then you can get on with that exercise. We have to work out x and y again in this case. Now have a think, which one are we going to find out first, the x or the y? Well, it turns out that x is the easiest one to find because it's one side of a right angle triangle and we have the other two sides. It's not the hypotenuse, so we're going to do a subtraction here, and we're going to work out that x is going to be the square root of 9 squared take away 5 squared. So if we work out what that is, we're going to get an answer of 7.483. Rounded perhaps to 7.5, but I use the 7.483 because I want to include that in my calculation so I get an accurate answer for now finding y, because I'm going to need that to find that y. So now if we look at the larger of the two triangles, we can now know that the base of that large triangle is going to be 4 plus 7.483. So y is going to be 4 plus 7.483, so 11.483 squared plus 5 squared, all square rooted. And that works out to be 12.5 to 1 decimal place. And that's how you do those questions. You now have enough information to complete the exercise. Good luck.